Hi everyone, welcome to another one of our short video series. In this video, we'll learn how to use lens formula to solve problems. Recall in the previous video that in the case of a converging lens, there are different images that correspond to different object distances, which is the distance of the object from the central axis of the lens. The object distance, image distance, and focal length is related by a formula, which allows us to calculate any one of the three given two known values. The alternative to finding the variables would be to use a light ray diagram that is drawn to scale. This formula is easy to remember as it is similar to finding the total resistance in parallel. What do the notations represent? F is the focal length, B is the image distance, and it is measured from the image to the optical center. U is the object distance and is measured from the object to the optical center. Let's see how to make use of this formula using an example. An object is placed 20 cm away from a convex lens of focal length 10 cm. Calculate the image distance. Since we're given the object distance and focal length, we simply have to substitute the values into this equation. Then it is just a matter of simple algebra and the image distance can be found. Here's a question for you. Why is it unnecessary to change the units to meters? Under what circumstances do you need to do so? In our case, our answer of 20 centimeters is a positive number, and this means that the image is on the opposite side of the object. Therefore, the image must be real and inverted. This can be verified by a light ray diagram. In our example, the object distance is twice the focal length, and the image is indeed 2 focal lengths away. Let us see another example. In this example, an object is placed 8.3 centimeters away from a convex lens of focal length 15.2 centimeters. Calculate the image distance. Again, since we are given the object distance and the focal length, we simply have to substitute the values into this equation. This time, our answer is minus 18.3 centimeters. The implication of a negative number is that the image is formed 18.3 centimeters away from the optical center on the left side of the lens, which is the same side as the object. Hence, the image form is virtual. If this equation uses a negative focal length, then the lens is a diverging lens rather than a converging lens. The lens equation can be used to calculate the image distance for either real or virtual images, and for either convex or concave lenses. That's all for this video. Be sure to check out our other videos.